Hello scholars, welcome back. Mr. Hinkle here, and I want to go over foundational concepts in geology. Now this is a very short list, giving us the big three huge shifts forward that we saw for geology to be understood as a science in the context of geologic time. So it goes like this. Nicholas Steno in the 17th century started to observe strata, or layers of beds, sedimentary beds. And what he noticed is that there was certain relationships and certain principles that applied to the stratigraphy which he was observing. Now, these relationships became Steno's laws of stratigraphy, of which is the topic for our lecture on relative dating techniques. So Steno's laws of stratigraphy were huge because they opened the door to understand the relative ages of different sedimentary rocks. This rock is older than that rock is younger than this rock. This is how they relate. Huge concept. James Hutton, the father of modern geology. So James Hutton was a Scottish naturalist, and around this time, geology is for fun. It's a hobby. There's no geologists. You have rich people who have done so well in life that they decide they want to spend their time studying and thinking about the earth. Awesome, this is the origins of geology. So James Hutton is studying the earth and he's looking at it, and he goes to his famous outcrop on the coast of Scotland. It's called Siccar Point. And as he's staring at this exposure of different rock layers at the surface, he goes, wow, the amount of time that it took to create this is unfathomable. I can't even imagine. Because he's looking at sand on the beach, and he's looking at rocks that are made of sandstone, and he's going, the processes that are happening right now on the beach are the same processes that created these rocks on the cliff. So what's making the sand turned into these rocks, and for that to happen, wow, that took a long time. So he viewed Earth as constantly changing, renewing itself, and existing over vast periods of time. Remember, this is after James Ussher, but before Lord Kelvin, so nobody really knows. There's no idea. How old is the Earth? I don't know. Do you know? I could try and think about it, but what James Hutton did is he said, everybody is wrong. It's much older than what anybody is thinking. And as he was looking at the sand on the beach and the sandstone on the cliff, he developed this idea of uniformitarianism that says chemical and physical laws of nature have not changed over the course of Earth's long history. Basically saying, whatever made sandstone hundreds of million years ago was still happening now. So maybe we study what's happening now, we'll understand what's happening in the past. Anyways, he wrote a big long book that nobody could really read. It was very dense, and he wasn't a great public speaker. So in comes Charles Lyell, who was able to take Hutton's ideas of uniformitarianism and present them in a way where people are like, yeah, you're right. He wrote this book called The Principles of Geology, and in it, he coins the term, the present is the key to the past. Now this is huge. The present is the key to the past. Meaning, let's study processes, geologic processes that are happening in order to understand geological formations that have been around for a very long time. With that underlying knowledge that these things take time, lots and lots and lots of time. So if we can look at how the Earth works today, we can understand how it operated in the past, and we can even make predictions about how it will operate in the future. So these were some big leaps forward, foundational concepts. Steno's principles of stratigraphy, James Hutton's idea of uniformitarianism, and then Charles Lyell presenting this with the phrase, "The present is the key to the past." Thank you.